Hey everyone, it's Justin again. This video's purpose is to help you check your work on the second problem in the additional practice section of your PDF for the Analyzing Functions Part 3 lesson. If you haven't worked through this as much as possible on your own first, pause the video and do so now. This example problem asks us to analyze the graph of the function to define the function's attributes using interval notation where applicable. Let's start with part A first. Since this function is represented by a single unbroken line, it is a continuous function. The domain includes all of these real numbers from 1 to negative infinity on the left and 1 to infinity on the right. We know this because of these arrows on the function indicating that the lines will continue forever in each direction. Our interval has curved brackets since negative infinity and infinity are concepts rather than actual numbers to include in an interval. As for the range, that includes all of these real numbers from negative 8 to positive infinity. These arrows are what tell us the function will continue forever to positive infinity. Here we use a square bracket since we are including negative 8 in the interval, and a curved bracket again with infinity. The y-intercept for this function can be found here at 0, negative 6, where the function crosses the vertical y-axis. As for x-intercepts, they're found where the function crosses the horizontal x-axis, which happens to be in two places, here at negative 3, 0, and here at 5, 0. Next up, we are looking for any intervals where the function is increasing. Reading our graph from left to right, we can see the function is increasing at this interval, which we can describe as all of the x values between 1 and infinity. Since a function is never increasing or decreasing at the beginning and end of the interval, we use curved brackets here to indicate that 1 and infinity are not included in this interval. And finally, reading from left to right, looking for any intervals where the function is decreasing, we can find that this interval is decreasing and can be described as all of the x values between negative infinity and 1. Again, since a function is never increasing or decreasing at the beginning or end of an interval, we used curved brackets here to indicate that negative infinity and 1 are not included in this interval. Really well done. I'll meet you in the next help video when you're ready to check your work.